Hi there. In this video, we are going to derive the difference formula for cosine. Now, we're going to do it by using this picture here. What I've done is I've got a unit circle, and I've picked 2 points on the unit circle, A and B. All right. The angle from the x-axis to A is alpha. The angle from the x-axis to B is beta. And what that means is that the angle between A and B is alpha minus beta. Now, in order to derive the formula, we are going to do something which isn't obvious, but it's going to work. We're going to compute the length of the line segment between A and B. Now, how do I get the length of a line segment between 2 points? Well, there's a well-known formula for this called the distance formula. The distance formula says that the square of the distance between any 2 points in Euclidean space is given by the difference of the x-coordinates squared plus the difference of the y-coordinates squared. And that's a very important formula that you should, if you don't know it already, you should definitely put it to memory. It's very useful. Now, where does that formula come from? Well, it's very simple. It comes from the Pythagorean theorem. For that, we need a right triangle, right? But you can easily form a right triangle here. We can just extend a line down from A and then make a right angle over to B. So we've got a right triangle here. And when we have a right triangle, the Pythagorean theorem says that the hypotenuse squared is the base squared plus the height squared. Now, what is the length of the base? Well, the length of the base is just the difference of the x-coordinates, and the length of the height is just the difference of the y-coordinates. And so that's where the distance formula comes from. It's actually quite simple. So we're going to do that here. We are going to compute the square of the distance between A and B. Now, we're going to do this, since we want to prove a formula for cosine, we're going to use trig functions to do this. So I have to think about, how do I find the x-coordinates and y-coordinates of the points A and B? Well, we know that because we know that's what trig functions do. The cosine function gives us the x-coordinate. If you take the cosine of the angle, in this case, for this point, the angle's alpha. So I'll take cosine of alpha to get the x-coordinate of A, and cosine of beta to get the x-coordinate of B. So the difference of the x-coordinates is just cosine alpha minus cosine beta. And I'm going to square that. And then I'm going to take the difference of the y-coordinates squared. Well, the y is given by sine. That's how sine is defined. So the y-coordinate of A is sine alpha, and the y-coordinate of B is sine beta. So the distance formula says to square that, and it says to add these together. Great. What we're going to do is we're going to expand this out. Here I've expanded out the first part. Now I'm going to expand out the terms with sine. Okay, what can we do here? Well, something should jump out at you right away. Do you see it? Yeah, we have sine squared alpha plus cosine squared alpha. We have an identity for that. The Pythagorean identity says that no matter what angle alpha is, this will always equal 1. And the same thing for sine squared beta plus cosine squared beta. That will always equal 1. So here we have 1 plus 1. Okay, great. So this is our formula for the distance squared, just expanded out. All right. Now I'm going to do something here. I'm going to manipulate this picture a little bit. I'm going to shrink the angle beta down to 0. But when I do this, I'm going to keep the angle in between these two line segments here. I'm going to keep this angle fixed. All right, here we go. Shrinking that angle beta down to 0, right? So what has happened is that this interior angle, alpha minus beta, has not changed. It is the same. Moreover, this distance between these 2 points has not changed. I'm now calling them P and Q. They're different points, but the distance between them is the same as the distance between A and B. So now what we're going to do is we're going to compute the distance between P and Q, the distance squared, that is. And we're going to go about it the same way. We're going to take the square of the difference of the x-coordinates. So now the x-coordinate of P is just the cosine of this. And the x-coordinate of Q, you can see, is just equal to 1 because it's the unit circle. So this difference of the square of the difference of the x-coordinates is. And what about the difference of the y-coordinates? Well, the y-coordinate of P is sine of this angle, alpha minus beta. And the y-coordinate of this point Q is clearly 0. So I don't need to subtract anything there. So now what I'm going to do is I'm going to expand this out. So here I've expanded this term out. And I'm just going to write this term next. Ooh, running out of space here. All right. Okay, so what can we do next? We'll take a look at this one and see if you can see it. Do you see it? Do you see the sine squared and the cosine squared of the same angle? Yep. So again, from the Pythagorean identity, that's equal to 1. So that stuff's equal to 1, plus 1 is a 2. Okay. Now, what did we say? We said the distance between A and B is the same as the distance between P and Q. And you saw that in the picture. As I rotated this, that distance did not change. And so these two quantities are equal. So I'm going to set them equal to each other. Now, if I set them equal to each other, I can subtract 2 from each side, and that crosses out, that kills the 2's. And then I can divide everything by negative 2. And what do I get left over? I get the formula that we were after, the difference formula for cosine.